Cool. So, hello, welcome. I'm streaming on YouTube for the first time. Usually I stream on Twitch, so we'll see how this goes. It opens up a whole new world of technical mishaps that can happen. All right, so today we are looking at the source code for MAME, which is a fairly broad emulator for video games, mainly arcade games, as I understand it. I think it also has kind of plug-in support for other video game systems like the Nintendo Entertainment System and the Sega Genesis. Certainly the older systems. I don't know how it achieves that. I kind of have a vague recollection that it does that via other projects. Like I'm not sure if that's part of the same code base, but we'll see how that goes. There's also something called MES. I'm not sure how that's related. The multi-emulator super system. And I guess MAME and this other MES project kind of merged. And so we'll see what it does when we look at the code. So I've got the code open here, their GitHub page, and let's see what we got. Artwork could potentially be interesting. This might be emulator or game related, or it might just be related to the MAME website. I don't know what BGFX is. Maybe that's B graphics. I guess let's look at that. Attic might be old code. We'll just check that. Docs and Doxygen are going to be documentation related. Controller might be video game controllers. I don't know what hash, Hilsel, or any are. Maybe I'll take a quick peek just to make sure I'm not missing anything too fundamental. Key maps and language, I'm going to guess, are not so core to MAME. Plugins, potentially. Projects, I'm not sure. Regression tests, that's good to see, but maybe let's not look at that now. ROMs, I'm not sure what this is. I don't think MAME comes with ROMs, but maybe it does. Samples, I think, will be good to look at. And I guess let's open scripts and tests. Presumably source will be the main place where stuff is happening. Okay, so that's I think that's good for now. Let's take a peek in source before we get to all the other stuff. In source we have devices, emu, which I suppose is probably emulation and not the ostrich-like giant bird. And then we have front end / MAME, lib, MAME, OSD, which might be on-screen display tools, and Zexal, which kind of sounds like it's an antidepressant. I'll pull source into its own browser window, and we'll come back to it and just kind of try to process through all of these other folders relatively quickly. So we have the artwork folder, chess. I don't know what chess and BGFX are. Chess pieces. Place chess pieces. Place chess pieces for use with internal artwork here. I don't know if you folks can hear it, but there's a gigantic storm raging outside my window. All right. Each SVG is expected to be square with transparent backgrounds. Let's look at the SVGs. Are these literal chess pieces? Will it display them? Yeah. Okay, so this is the classic chess font. What is this? Staunton, maybe? A? How does this spell? Staunton with an O. No? For some reason, IceCat's not going to load images from Wikipedia. Huh. I don't know if this is Libre.js or what. Let's try just an image search. No, I don't know. Okay, yeah, I think it is based on the Staunton design. Anyway, I'm not sure what they're doing with chess pieces. Let's see what is BGFX. Border blur and chains. CRT geom, is that Cartesian geometry? Aperture, delta. I don't know what that is. I'm not sure if IceCat is refusing to download things, or if something else is going on. You know what? I have the source code. I have the source code downloaded. So let's see if Emacs will display stuff. Okay. So what are chains? I don't know. Will it display anything? What is the window manager called? Thunar? Okay. Yeah, they're little tiny things, I guess. Okay, maybe we can figure out what those are by looking at the code. Huh. Things are blowing across my window that should not be blowing across my window. All right. So aperture is this kind of trippy looking pixel stuff. I wonder if this is needed to emulate different kinds of like CRT displays, because these seem like these are red, green, blue pixels. Let's see if we can find what a close-up of a CRT screen looks like. I'm being redirected to a non-JavaScript site. Okay. I'm still using Geeks, which I set up in another video, but it seems to be kind of getting in my way a little bit, at least on IceCat. Okay. Yeah, okay, so here's what a CRT pixel looks like. This looks like the same sort of thing that's going on with MAME. So I'm going to guess that that's what's going on with MAME. Where's Thunar? Okay, and then chess. We have the chess pieces and anything else of interest. I'm not sure. All right, so that's artwork. What else do we have? Here's BGFX without artwork. BGFX shaders contains definitions for BGFX shaders, shader chains, and effects. Okay, so chains are probably shader chains. But what is BGFX? So if we go into shaders, I guess metal. We've got these .bin files. I don't know what a .bin file is going to do. I don't know if it's raw binary, but I guess it will. I'm going to guess it is. What's in DX11? Okay. And then chains. CRT geom, default eagle, miss, .bin file. Now I think, so let's go back to Emacs. And let's take a look at the fighters.json. Where were we? We tried metal. So let's see if I can find out what kind of file this is. Hey. Maybe I can install the file utility. Oops. I can't spell. All right, you download that. Oh, that was pretty quick. Data. Okay. So it's some sort of binary data, I think is what that means. And then in back BGFX, we had, what was it? Is anything interesting in effects? Okay, we've got some JSON files in effects. So let's see what GUI multiply.json is. It's got some blend stuff, some depth stuff, call, write, vertex, fragment, uniforms. All right. So let's look up BGFX. List of 3D graphic libraries. High-level 3D API. Scene graph. Cross-platform rendering library. Graphics API agnostic, bring your own engine or framework style rendering library. And then it supports a bunch of rendering backends like Direct3D, OpenGL, Vulkan, WebGL. Okay, so it's kind of an abstraction layer over the various lower level 3D graphics libraries. Okay, so now here we are in the MAME/addict directory. And what makes this addict? We've got Jcrypt. This file is not part of MAME. It is here to provide detailed documentation of the encryption used by junior Pac-Man ROMs. Huh. Well, that sounds kind of cool. So we've got some table. Yeah, I'm not sure if this table is like a key. What is it called? It's called just a junior Pac-Man table. Pre-decrypted ROMs. Then we've got some sort of machine reset macro. And more pre-decrypted ROM stuff. We've got a word bit. And we're going to take the word and we're going to shift it by the bit. And we're going to AND with 1. Let me make sure my phone is off. All right. Okay, so here we've got a big comment. This function would look surprisingly similar to the source code to the encoder pals, I imagine. To the encoder pals. I think there's something TV related called pals. Unless I'm misremembering. Pals. I'm not phase alternating line. I'm not sure if this is related, or it's just meaning encoder friends. I wrote is based on the JDEC file that I got from VideoDoctor. It needs to be run during the game since the logic is kind of weird and state-based. This is slow. Okay. Yeah, this is kind of crazy. Is this a custom encryption scheme? And how did they even reverse engineer this? I don't know, but that's somewhat interesting. Okay, what else do we have? Actually, let's go back to, since that was interesting, let's see what else is in attic. FD debug, Jalma, Jalico Mahjong code simulation snippets for first MCU games. And this looks kind of like assembly. What is opwolf? Operation Wolf C-chip protection simulation. The below simulation was replaced by emulating the actual C-chip using an extracted EPROM image. Okay. The C-chip is an unidentified mask-programmed microcontroller of some sort with 64 pins used for copy protection. It probably has about 2K of ROM and 8K of RAM. The simulation in this file is verified from the unprotected prototype game and the observed behavior of the real PCB running. It should give 100% accurate gameplay. That's kind of fascinating. There's a lot of effort, I guess, put into making this stuff playable. So this is some sort of copy protection. I guess if I don't know much about chips or the hardware world, but maybe this is relatively straightforward to do. If you what happened to IceCat? If you oh, here it is. Wait, did I just switch? If you know what you're doing. But I certainly don't know what I'm doing with respect to hardware. And I'm guessing that whoever made this protection were trying to roll their own kind of security measures. And they were able to be defeated, I guess. So that's that. So we have, here we are in controller maybe. Hot Rod and XRK. Let's look at those two just to see what this directory is about. There's not a README. Let's see. We've got this CFG file, which I guess is config. This looks like XML. We've got keycode up, keycode down. This does look like gamepad stuff. And coin 1, coin 2, joystick. Yeah, so this is some sort of gamepad configuration. X arcade. Yeah, okay, so this is some sort of gamepad configurations files. Hash. Okay, Alice32, Apple1.xml, Archimedes ROM. So let's see what's in these files. More XML. What's the file extension? Yeah, okay, .xml. We've got a software list, a software with a name, description, publisher info, more software name, and we've got SHA-1 hashes. So maybe these are hashes of the files that MAME can't include. So let me pick a system that I'm at least somewhat familiar with. What do we got? NES. Let's look at NES. This file's too big for GitHub to display. Okay. All right, note on the file names. Whenever a chip was labeled, the label writers have been used as file names, so that in principle one could burn back the content on the right chip. When no label was present in the cart PCB, we have arbitrarily chosen the names 0.prg and 0.chr. All right, so is this per game? It does kind of look like per game. What about Zelda? So here's the Legend of Zelda USA. The software name is Zelda. It's a clone of Zelda. 1987 is the year. We've got some sort of serial number, a release. I don't know what the XX is. Maybe 07 is the month. Part name cart, which I am guessing is cartridge. There's a PCB. I don't know what MMC1 is, but maybe it's some sort of chip or memory. Data area. And a SHA-1 and an offset. Okay, so this is listing hashes of something. Of the ROMs, maybe? Maybe these are hashes of the ROMs. Or somehow it seems like they're hashes of whatever is in the chip. And I think that ROMs are whatever was in the chips, kind of like the starting state of the game that comes when you buy the game. And then the logic is somehow encoded between the hardware and the PCBs that come in the console, and then the cartridge has extra logic. I think the cartridge contains like a PCB, is how it worked. I'm not positive, but that's going to be sort of my mental model looking at this. All right, HLSL. I don't know what this is. Everything has an FX file extension. It seems to be something video related. So we've got bloom, chroma, color, distortion, downsample, focus, NTSC, which I believe is some sort of TV broadcast standard, prescale, primary, scanline, and vector. Let's look at scanline. Okay, so you've got texture diffuse and diffuse sampler. This looks like C++ to me. Maybe this is just a C++ with a special extension. We've got some structs, inputs, output, screen dimensions, vertex shaders. Yeah, this is some sort of vertex shady thing. I don't know enough about graphics to know. I'm guessing they use BGFX for the graphics library, so maybe it's a BGFX thing. Okay, so in I&I, we've got presets and examples. Let's look at Game Boy. Shadow mask tile. So these are direct 3D post-processing options. So I guess this is making things look more Game Boy-like. Or if you're using LCD, different options. Okay. What are examples? P3, phosphor, medium persistence. Okay. Projects. This is a place where source code projects outside of MAME lives. Here you can git clone that kind of project and make it with make project equals example. Okay. Sounds good. ROMs. Restore this. It's used when building packages. dir.txt. Place ROM directories here. So this is where you will put your ROMs if you have MAME. But do you need to, I don't know. Do you need to build MAME with the ROMs? I'm not sure you do. Let's see. What did it say? It said it's used for something. Oh, what was that? That was the commit. Will it load the commit? It's used when building packages. Okay. I'm not sure. Maybe it's used by some sort of testing. Okay, here we are in MAME samples. To make mechanical sounds of various machines available in emulation. Okay, cool. What is dir.txt? Place samples directories here. I wonder if I can play this. I don't think I have I don't think I have any sort of sound playing application. Okay. Oh well. All right, scripts. Build, font, mini MOZ, resources, source, target. So these scripts are in Lua. And I've never actually read any Lua, but this looks reasonably easy to understand. I guess let's not look at that too much. Okay, here are the MAME tests. We've got emu and libutil. A to time gets its own test. And then we have RBG util has a test. That's not a lot of tests. I wonder if there are more tests. Chorister. Is this like a string library? Kind of looks like a string library. Okay. Are there no other tests? Where was that MAME test? About in source? Doesn't seem like a lot of tests. Okay, so I already had source open. So let's go there. All right, so in source we have devices, emu, which I've been calling emu, lib, MAME, OSD, tools, Zexal. We have to know what Zexal is. Tools, we'll assume is just some sort of util directory. And let's look at MAME as the first. Okay, so this is pretty interesting. So we've got chess, apple. I don't know what beehive is, but a lot of these are look like old arcade game or console companies. Acorn, I think they made some PCs. They may have made games. Akai, Alesis, Alpha, Altos, Amiga was a computer manufacturer, I think. Apple, they made some computers back in the day. Chess, Chromatics. Let's see. Are there also F-32? Let's take a look at that. I'm wondering if that's something I'm familiar with. Okay, F-32. Is there a comment? FE132 driver. No, I don't know what that is. Okay. All right, what else do we have? Game Park. Grundy, Home Lab, Husky, Intel. Let's look at Intel. Luxor, Mchester, Microsoft. Let's look at Microsoft too. And NEC. These all seem to be computers. Like, I don't know if are there any game systems here? Sega. Is Atari here? Atari is here. And AT&T. What about Nintendo? Yeah, Nintendo's here. Okay, so let's just take a quick look at some of these. So Intel, I don't know what any of these are. MCS Basic 52 is basic related to the, we've got a URL. Let's take a look what this URL says. MS31 Basic System Development Board. Is this related to the basic programming language? Old Basic 52 interpreter. Okay. Yeah, seems to be. SDK 86. Intel MCS 86 System Design Kit. This is an evaluation kit for the 8086 CPU. Okay. So what of these things has? It's got some state. It's got a function called scanlines, IO map, memory map, machine start, and there's a bunch of low-level kind of table-y stuff. x86 state digit W. If m digit is less than 8, m digits at m digit is equal to data. Okay. Basic machine hardware, video hardware. Okay, some sort of emulation stuff. All right, Microsoft. Oh, Xbox. That seems to be, relatively recent. They didn't have that in like the 70s or 80s, 2001. Okay, so what is going on in the Xbox? You've got an Xbox state. MIDE, DevH, and DevC, which are the CD-ROM. DevH is the hard disk. DevC is the CD-ROM. IDE is maybe another hard disk. You've got Xbox map, which is an address map or something. Input port start. Port start CISA. Dip name, dip settings. Are these pins? These might be like pins for some chip. Hack EEPROM. Main CPU space 0 write byte. Some magical byte. And same with whatever main CPU space 0. Wait. Remove audio wait, disable boot animation, and internal hub not used. Okay. And then we can start the machine. We can reset the machine. We can add devices, ATA devices. We can load BIOS. All right, so that's Xbox. So what is Jazz? An emulation of systems based on Jazz computer architecture, originally developed by Microsoft. Specific systems which implemented this architecture include the MIPS Magnum/Millennium 4000 and the Olivetti M700-10. So some sort of MIPS architecture. Let's see what linuxmip.org says. Is it going to load this URL? I guess not. Okay, so here's Sega, and we've got a bunch of different things. I'm guessing these are all kind of similarly low level. Gunsense.cpp. Sega Gunsense. A Gunsense board. Gun board was based on big number of Model 2, blah, blah, blah. Lindbergh Games. Arcade spare parts. Hey. So is this a light gun? It'd be nice if I could go, what is it? No, I can't. I'm not sure if there's a way to get back ordinary JavaScript right now. Okay, so in MAME/Atari, we've got a bunch of stuff, like the 2600. VCS 2600 driver. To do, move the two 32-in-1 ROM dumps into their own driver. Add 128-in-1 driver. The TV Boy 2 and Super TV Boy units did not have joystick ports, but a built-in D-pad. Find, dump, and add the other variants. There are many. All right, so what do we got here? We've got some base state, M-Riot RAM, some joystick stuff, a screen. I don't know what XTAL is. Memory, X2600 base NTSC, base PAL. We've got some state that's being managed by what appears to be a stack. A ROM switch, timer, callback member. TV Boy memory, TV Boy member. Okay. There are a few games that do an LDA Y instruction. The contents off the data bus then depend on whatever was read from the RAM. To do this really properly, the 6502 core would need to keep track of the last data bus contents so we can query that. For now, this is a quick hack to determine that value anyway. Examples: Cuberts, Cubes, and Berserk. Okay, so here's Nintendo. We get some files for specific games like Donkey Kong. We've got GameCube, which is a console. We've got Mario, which is a character, but is also possibly the game. NES and N64. And yeah, PunchOut. What is PunchOut? I wonder how it determines that a game deserves its own emulator file. Okay, so for the schematics, xtal is 6144 megahertz. There's some oscillator logic behind it. The oscillating circuit transfers the signal with a transformator. Onwards, it is fed through the M/B/C 10136. This is a programmable counter, which is used as a divisor by 5. Cascaded sum chip further divide the signal. The following signals are generated. Some various signal megahertz thingies, a pixel clock, and a CPU clock. The horizontal circuit counts till 384, thus 256H only being high for 128H over 2. Sounds like they're doing some fancy stuff. This is what Donkey Kong... Nintendo Donkey Kong hardware. Oh, maybe this is the... this is the Donkey Kong arcade game. We've got a main CPU, a sound CPU, EEPROM. Huh. Okay. Very cool. I don't think there's a year. What would it be, 1980 something? All right. So here's Donkey Kong.cpp. And I guess we don't really need to look any further at this. Well, maybe we do it. The DMA 8257 is responsible for copying sprite data to whatever this other thing is. 2650 based games had a ROM for address lookups. This is needed for proper operation of the 8257 code. Where this was missing, I copied the entry from HunchbackD and marked it as bad dump. Additional protection was done by PALs. The only driver with a PAL entry is Herbig. So this is both for Donkey Kong and Donkey Kong Jr. And we get some, let's see, there's some movement stuff. Where did that go? Okay. Bit 4, jump player 1. Bit 3, down player 1. 2, 2383. Donkey Kong Jr. modification kits. Is this an email? It has come to our attention that playtime on Donkey Kong Jr. is, in some cases, excessive, while in other cases there is a concern over the ability of players to learn the game and thereby retain an interest in playing. We are making available through our Nintendo distributors 2 EPROM change kits designated DGR1E and DGR1P. The E kit consists of 4 chips and is an easier version of the program. It presents the board sequence in a way which familiarizes the players with the game faster. The board order is Vines, Springboard, Mario's Hideout, and Keys. The P kit is a more difficult version consisting of 2 chips. The order remains the same while more and faster obstacles, snapjaws, nitpickers, etc. are presented. This seems like this might be a real memo. Let's see if we can... probably not. Because our version of DuckDuckGo is very limited. What if I just grab the first sentence? And what if I try to search Google? Okay, that literal string's not finding any results. I'm not sure where that thing is from. That thing that looked like an email. Okay, so GameCube. This is obviously a much more modern system than Donkey Kong Jr. or Donkey Kong, and it looks a lot like the Xbox One. What does this function do? GameCube state decrypt. Boot ROM descrambler reversed by Segur. All right. So they reverse engineered some, I guess, custom decryption function, or maybe just the key. There are a lot of bad dumps of the GameCube IPLs floating around. The following IPL dumps are known bad, and we get the SHA hash of the dumps. And then we load some ROM stuff. Cool. Here's Mario. I'm guessing, based on our experience with Donkey Kong, that this is the Mario Brothers arcade game, assuming there was one. And let's skip. Was there a PunchOut arcade game? Okay. Can we buy one? Yeah. No PCB. Okay, so if you want the PCB new, I don't want it new. Come on. Do I not have access to the... I can't... Yeesh. I'll have to figure out how to get something more like regular Firefox on Geeks. You assume it's possible with some work, or... all right, whatever. Okay, Zexal. What is Zexal? Main.cpp. Controls for the core Zexal system. Zexal Machine Manager. Is this an existing arcade thing? The Zexal and Zexdoc. There are two versions of the program using Z80 instruction exercisers. The Z80 core. Emulating every Z80. What is Z80? An 8-bit microprocessor introduced by Zilog, the startup company's first product. Okay. Is Zexal related to them? Maybe. I don't know. Maybe it's an emulator of that thing that I just looked at. Okay, here's source OSD. And what do we got? OSD file, OSD depend, watchdog, string conversions, SDL Mac interface modules Windows, bit scan reverse, inline bit manip. So this is like bit manipulation functions, as it says. OSD file, the prototypes. Okay. Core OS dependent file interfaces. Oh, OSD, I guess, stands for OS dependent, not on-screen display. Okay, sounds good. MAME source lib. We've got formats, netlist, and util. I don't think any of them are going to be super fascinating. So documentation, frequently asked questions, setup, types, formats. That's okay. I don't... Let's look at bitmap.h. Core bitmap routines. So these are like bitmap functions, a bitmap API, if you will. So here we are in EMU, and this is probably where a lot of the real stuff happens. Let's look at MuCore. Maybe MAME. HTTP. Why do you need an HTTP library? MAME. Recording, render. Yeah, render seems interesting. Sound, video, xtal. I don't know. I still don't know what xtal is, but it sounded like maybe it was something video related. Okay, so we'll just take a look at a few of these before we head out. Debug, drivers, layout, UI. Let's at least just see what's in these different folders. UI is not much. UI main is very small. Okay, not much there. Video, we've got some RGB stuff. ResNet, generic. What does generic do? You've got graphics layout, planar, just extern constants. Okay. Layout, monitors, and NES ROM, no screens, smartboard. Layout files are definition files to describe the look and feel of emulated machines. They are a product of many different contributors. Sounds good. Drivers has empty and test CPU. Debug stuff is maybe worth going into if you're trying to debug something MAME related, but right now I'm not. So here's MuCore, general core utilities and macros used throughout the emulator. All right, so what are we including? Forward declarations, stuff from libutil, stuff from OSD, standard C++ stuff, and then things like assert. Standard C includes. Okay. All right, useful composite types. A pair is an endian safe union useful for representing 32-bit CPU registers. More pairs, some endianness stuff, constants describing endianness. Common macros. Name. This macro passes an item followed by a string version of itself as 2 consecutive parameters. Okay. This macro wraps a function x and can be used to pass a function followed by its name. Interesting. That seems kind of convenient. It's kind of like quoting. It's kind of like, yeah. It's like an injection into the space of real and quoted values or something. Something like that. All right, macros to convert radians to degrees and degrees to radians. Cool. But are they typed? So we've got auto. Are they just floats? How do you know whether a function wants degrees or radians? That's my real question. Okay, so MU exception is a base class for all emulation-related exceptions, fatal error, casting templates. Okay, so we're going to report bad cast, downcast. All right. This actually looks relatively clean. I kind of like it. Inline functions. We're going to inline some stuff. Convert a float to a series of 32 bits. So we're going to have a float, and we're going to get U32, a single U32, right? And it's an inline. And we're going to have a union of a float and a U32 and assign F to it. And we're going to return U.VV. Huh. I'm a little bit surprised this works. So we have a float. We have a float, and we have this union type. And we're going to assign the float to the floaty part of the union. And then I guess for free, the U32 part, because it's the same place in memory, I guess. Is that what's going on? I don't know. MuCore.cpp. So here's the was I looking at the header? Because there's a lot going on there for a header. Okay. And there's not much to do here because they did a ton of work on the header. Okay, emu.mem. Don't include this file directly. Include emu.h instead. Functions which handle device memory accesses. This seems like something that would be hard. A hard part of emulating many different machines, because it seems like there would be a lot of like special cases, corner cases, I guess, is what I'm thinking. So read 8, read 64. Wow. Oh, Lord. What are these? Okay, so these are templates. We've got a type name T, a type name enable, RW delegate type. So, this is like overloading a bunch of read 32 delegate stuff. Okay. Kind of like compile time, giving you access to a bunch of different functions. The wind continues to go crazy outside. Address segmentation for the search tree. Handler entry dispatch level. So I have no idea what this is doing, but just to get a sense of it, we're going to return. High bits is going to be shifted over 48. And there's this ternary operator. And if it's 3, we're going to do high bits shifted 32. Or if it's 2, we're going to high bits shifted 14. And there's 2 more ternary operators. Okay. Right. I wonder if this is... that's kind of like a decision tree. Is that what it means? So we're going to do some tests. And based on the results of those tests, we're going to get one value or another. And the tests seem to be related to these shift operations. We're like cutting off bits, which is maybe a little bit like modular arithmetic. So I don't know if that's the right way to think about this. All right, handler entry dispatch level to low bits. Handler entry dispatch low bits. Memory pass-through handler impl. Pass-through handler management structure. I don't know what we're passing through to. Okay. Or maybe it just means that the handlers don't do any changes. I don't know. All right, handlers. Handles, I assume it means, the ref counting as part of the interface. The root class of all handlers, and they're going to do some ref counting. All right, it provides the populate read get pointer lookup API, the parent class of all read handlers. Okay, yeah, this is super complicated. In fact, this is certainly the most complicated file I've looked at in this code base. And this is arguably the most complicated file I've looked at in this whole series so far. This is a thing that you want a ton of tests for. Right? Is this one of the things that they were testing? Let's see if Emacs will help me here. We've got some just grepping for test. Oops. Scripts. Third-party stuff. I don't care about the third-party stuff. Oh, it's still grepping. All right, stop. That'll be enough. Let's grep and source. There's also a thing that mentioned test, but I don't think there's a lot of actual tests. Was test its own directory before? Tests. Emulation. So yeah, we've got 8 to time in video. I wonder if they have like a scripts. I don't think has any tests. Oh, we have regression tests, which is nice. But these are like bugs, right? So a regression test, at least in my world, implies that we encountered a bug, and we're verifying that the bug doesn't happen again. So I'm wondering though if there are unit tests. Projects, language, key maps. What if I just grep for unit? That seems like a bad idea. What if I just search for MAME unit tests? Is this actually a MAME thing? No. Okay. Yeah, I don't know. Maybe there are some secret unit tests, but with something this complicated, you would think that they would have a pretty robust test suite. All right. I'm sure, I'm saying it's complicated. I don't think the logic is necessarily complicated. I think once you know what you're doing, it's not like a complicated algorithm where you have to think about. It's mostly like adding and subtracting, but like off by one errors and like debugging something like that is super hard, and there's just so much there. And so much of it is kind of case logic. And if you get it wrong a little bit, you would expect the emulation experience to suffer dramatically, because now like memory management is not working. So it's complicated in that sense. It's like both. There's some amount of complexity. It's not the same kind of complexity as like, say, a hard math theorem, but it's. I'm wondering if I can think of a metaphor that works. None come to mind, but it's the sort of thing that I would prefer not to be responsible for. If this was the MAME corporation, I would want somebody else to be responsible for that file for sure. Okay, so here's HTTP. I'm just curious why they have HTTP server stuff. Web app connection HTTP request get fragment. So this just looks like an implementation of an HTTP library. Maybe we can see where in source some of this stuff is called. So how about WebSocket? In Sonic? The HTTP file. Devices bus /T199, sorry, TI99. But what does this do? Raspberry Pi? The Tippy adapter card, designed and realized by Matthew Splett. Pronounced Tippy is an expansion for the TI99. That's the graphing calculator, right? And other computers of this family, and consists of a Raspberry Pi computer attached to an adapter card. So this WebSocket in this case, I guess, is for communicating to from one device to another. It's not like a game is downloading web assets or anything like that. Client WSHPP, WebSocket client. Case insensitive equals okay. Server WS impl. Yeah, I don't know. What is the ESC panel? Is that similar to the Ensonic panel display device? External panel support. So maybe external means external, like you communicate it to it over Ethernet. I don't know, but that's a little bit surprising. But it seems like it's not being used for the game. It's more being used for communicating between different boards in one way or another. Okay, so here we are in render.h. These are the core rendering routines for MAME. A render target is 5 parameters: width, height, BPP, that is bits per pixel, orientation, and pixel aspect, the aspect ratio. So it's kind of like a scene. Is that the same thing as a scene? Scale fractional. Yeah, so this is also fairly complicated. Render tech info. Oh, text info, texture information. Unrelated, I guess, to the tech info tech documentation thing. Okay, render texture. We've got some friend classes. Simple list, fixed aggregator, fixed allocator, render manager, and render target. We've got some getters. We can set a bitmap. Some private methods: get scaled, scale texture. Okay, set user settings. X scale, Y scale. All right. I'm not going to look too much at the 3D stuff. I think I'm going to do soon a look at other 3D graphics libraries that will be more informative with respect to how 3D graphics is usually done. That I think is mainly more like wrappers around kind of exposing 3D stuff for the MAME developers, giving them a nice interface that they can use throughout the code base. Okay, render.cpp is going to be the implementation. Xtal. Documentation for known existing crystals. When you're 100% sure there's a given crystal or resonator on a PCB, use Xtal frequency to document so. The Xtal object then collates multiples or divides done to the base frequency to compute the final one. If you receive a Xtal object and want to turn it into a final frequency, use value to get an integer or d-value to get the double. If you receive an Xtal object and want to check if the initial crystal value is sane, use check context message. It will fatal error if the value is not in the authorized value list. It has a small cost, so don't do it on a hot path. Okay. Something to do with oscillators. Crystal. Does it stand for crystal? Is that a standard abbreviation? Xtal Inc. Xtal oscillator circuit. Crystal. Cool. Xtal redirects here. All right, here's crystal.cpp. This is a finite list of manufactured crystals. This file aims to document all of the known speeds that crystals were available in. Feel free to add to the list if you find another speed crystal on a PCB, but please don't guess. Remember that some very high frequencies, typically above 100 megahertz, are generated by a frequency multiplying IC from a lower frequency crystal. Cool. What is this? The frequency here. Sugarvast. I don't know what sugarvast means, but examples. It's, more like scientific notation. I mean, sugar vas. What is vas? All right. Sugar vas. Okay. So what's the fastest crystal? I think that's the question on everyone's mind. 200 megahertz crystal, base SH4 CPU, Naomi, Hikaru, etc. All right. What's the first fast crystal I recognize as? All right, how about Miss Pac-Man? It's got 73.728 megahertz. All right, and here we are in Apple, which I had opened a long time ago and completely forgotten about. But for the sake of completeness, let's look at the Apple II. Next generation driver, written in 2014. We have RAM sizes of 4, 8, 12, 16, 20, 24, 32, 36, and 48 kilobytes. That's pretty good. All right. We've got utility strobe, a speaker toggle, a cassette toggle. Did it have a cassette? Did it use cassettes for discs? Write line number. This code makes a ton of assumptions because we can guarantee a pre-2E machine. Okay. We can start and restart it. Pre-calculate joystick time constants. All right. Well, that's the Apple II. I'll scroll through and see if there's anything that jumps out at me. Cool. All right, so that's the first look at MAME. I don't feel like I necessarily understand everything they're up to, but at least we have a sense of how they go about emulating machines, where the machine emulation definitions are, and how the emulator core, what parts of it are difficult, and what parts can just be thrown into a JSON file or an XML file as config. That's all for me. Thanks.